All right, I'm your host, Alexander. This is a brief tutorial from Frozen Electronics, a subsidiary of Frozen Development, which you can reach at frzn.dev. We're going to be doing a little soldering tutorial for beginners. So I'm going to go over a few things. Right now, we've got this board. This is a Pimeroni ESP32 board. Or no, Pico boards are. This is a Pico Plus 2. This is the back side of the board. If I adjust the lights here, you should be able to see. There we go. That's the WinBond SPI flash chip on the back there. But we're going to be soldering on a header today. Now this is actually a double header, so it has the pins on the bottom and the female sockets on the top. And we're going to do one side with leaded solder, and we're going to do the other side with lead-free solder, because I want to show you the difference and, you know, how to work with both of them equally. It's important to be able to work with lead-free, especially if you're going to be doing any sort of manufacturing down the line. And it's just better. It's better for you. You don't have to worry about getting lead all over your hands. Lead solder still has its place for some applications, but lead-free solder, especially good quality lead-free solder. For example, I have this ChipQuick, this CQ100 GE is the equivalent to that AIM solder. I forget what the letter before it is, but it is also something 100. And the difference is this particular formulation. It's got 99.244% tin. Let me bring that into focus. 0.7% copper. And then the interesting things are the nickel, 0.05%, and just 0.006% of germanium. Now, the nickel replaces what would usually be silver in this, and it helps it flow a lot better. The germanium helps prevent dross, so you'll get less, you know, if the flux burns away or whatever, you won't, it makes the joints nice and shiny, basically. I think the nickel also contributes to that. This is really good quality lead-free solder. You can get this on DigiKey. You just look up that exact part number. You can just look up CQ100 and it should come right up. So that's what we're going to be using on one side. On the other side, I'm going to be using 6337 leaded solder from Kester. It's a kilogram roll that I bought about, oh gosh, I can't even remember, over a decade ago, and I still haven't gone through it all. So we're going to get the right angle here. I'm going to focus down onto the board. And one thing I want you to notice, let me get my iron out here. Just going to give it a quick clean. If you look at my iron tip, notice it's a flat tip, what we call a screwdriver tip or a flat blade tip. Now the reason I use this type is because it works exceptionally well for stuff like this, because it allows you to touch the pad. The pad is this gold portion here on the PCB and the pin at the same time, and you're able to touch a substantial portion of both of them at the same time. So let's see, I'm going to come in here with my iron, press down, heat it up, and then I'm going to feed in solder. Oop. Hard to do under the microscope here. This is a new microscope that I've never used before, so forgive me. But okay. Try and come in from the other side. There we go. That's good quality leaded solder. Okay. So there's one joint. I'm just going to check and make sure that, yep, okay, that header is nice and neat. So when we're inspecting the joint, let me turn up the light here a little bit because I think it'll probably help. Turn up that light, and we'll turn up this light, and we'll point these lights in the right spot. You can see that the joint is very shiny. If I go through the focus range here, you can see the leftover flux. That's the yellow stuff there. That's in the solder itself. I didn't actually add any extra flux. And if I look at it from the side here, you see we have, the important thing is the shape of that. Notice how there's a nice, what we call a fillet there. There's a little bit of extra solder on the one side, but that's okay. Not my best joint, but perfectly acceptable. Okay, so what I'm going to do now, let's focus back down. I'm going to go along and do a few more here with the leaded solder. Hopefully, if I should actually be turning this sideways like this. It makes it a lot easier to feed the solder in from one side and the iron in from the other side, which is what you ideally want. So, bring that back under. Okay. So I'm going to put the flat of the iron on both the pad and the pin at the same time. Then I'm going to feed solder in. Having a really hard time reaching in there. There we go. Do a few more. I don't know why I'm having such a hard time getting in here with the solder. Okay, there, that should be better. There we go. Might be a little bit excess. You can see all the flux on there. That's fine. We're going to clean that off afterwards. Ooh, I don't want to burn the light. So let's just lift that up a little bit and away. Yeah, this isn't the perfect microscope for soldering because there isn't a huge working distance. But again, see, I'm touching the pad and the pin at the same time. I give it a second to heat up, feed in solder from the other side, and we get a nice, shiny, perfect joint. Apologize if my hands are shaking a little bit. It's amazing how much you can see how much your hands shake on the microscope, but in real life they don't look like they're shaking at all. You can see all the flux bubbling up there, cleaning the joint. Now this is gold plated, so it really doesn't need any extra flux. The solder should take very well because there's no oxide coating. If this was copper or just tinned with solder, then you definitely want a good quality solder with good quality flux in it, or you want to add some extra flux yourself. Okay, let's see if I can just bust out the rest of this row really quickly here. Okay, I guess I should look through the microscope more instead of trying to look at it from my angle. And so once you get going, you get in a good rhythm here. Just getting a little more solder out. As you can see, this tip, I probably need to replace this tip fairly soon. The plating is starting to wear off. I've had this one on here quite a while. But I have been using tip tinner to try and prolong the life a little bit. Okay. I know it's bad, but I love the smell of the rosin in this particular Kester solder. Don't ask me why, but it has a very organic smell to it. It really does remind you of, like, you know, trees or, I don't know, some sort of plant. All right, we've got one whole row done. So that was done with leaded. Okay, now what I'm going to quickly do First, I'm going to turn that iron off to let it cool down. I'm going to turn my other iron on. I use a separate iron. So we'll let that heat up. While that's heating up, I'm going to wind up my leaded solder. And I'm going to clean this with Flux Clean, with actual Flux Clean, MG Chemicals stuff. I'm going to grab one of my anti-static cleaning brushes and a piece of paper towel. We'll see how we do here. Flux remover for PC boards. Whoop. Okay. And then we'll sop this all up with a piece of paper towel. I like to rub the paper towel with the brush. I think that helps sort of soak up any of the liquid flux clean that's saturated with flux. Alright, now if we take a look at the joints, let's see how nice and clean and shiny they are. They're still a little bit wet from the flux clean, and we've got a really nice finished soldering there. Well, there's a few little floaters from the paper towel. Okay, so now we're going to go to the other side. So we're going to flip the whole thing around. Again, I made a mistake with the first couple of joints there. It's all about positioning. You really want to position whatever you're soldering so that you can feed solder in from one side and your iron from the other. Now, this lead-free solder is very good quality, but with this stuff, just to give me a fighting chance, I like to add a little bit of flux sometimes, especially rosin-based flux. So I have here a flux pen. I'm just gonna run it down the whole length and just put a little extra flux on them. That'll just help the lead-free stuff flow. Okay. This particular formulation of lead-free actually also has a lower melting temperature than most lead-free. Most lead-free you have to get well up, well above 350 C, sometimes up to 370, 380, 390 for lead-free. This particular formulation, melts around the same that most leaded solders do. Now this wire is quite a bit stiffer because it's lead-free. Lead makes the lead-free stuff quite a bit, actually going to just tin the tip here, make sure it's hot enough. Yep. Clean it off. I need to get a separate cleaning thing for my lead-free stuff because I'm sure I'm getting a little tiny bit of lead on this, but I'm not exporting this. This is just for a tutorial. Alright, it's the same thing. Heat up both sides, feed it in, and look at that. Perfect joint. This is slightly thicker solder as well, so actually I don't need quite as much of it. That's the problem with my leaded stuff. I love that solder, but I wish I had bought just maybe one size up from that. Alright, it's the same thing. Touch both sides. Feed the solder in. Make sure it gets nice and hot. Okay. Oops. depth perception's a bit off there. Now, this is the thing about lead solder, or lead-free solder, that people don't like. Notice how it kind of acted weird there? That is because I don't have my iron set hot enough. Or actually, it's probably hot enough, but this is kind of a cheapo iron. It doesn't have a lot of thermal mass. And this particular type of solder should have what's called a eutectic alloy, which means it all melts at one particular temperature. I don't know if this is made exactly the same as the original Japanese formulation, because as you saw there, it seemed like we had what's called a slush point, where it's not all liquid. It could have also just been oxides on the solder. So let's just reflow that last joint there. Now I turn the temperature up a little bit there. That's better. And as you see, once you get everything set up correctly, this is just as easy as lead-free. Or as leaded, sorry. The only thing about this particular solder is that it does have a very different smell to leaded. Come on now. There we go. Notice how I'm getting nice flow now, and that's because I got the temperature set correctly. Okay, gotta spool out a little bit more solder. Getting these last half of this row done. Oops. The flux really does help quite a bit. And I mean, you know, most people will tell you should be using extra flux. I mean, there is no such thing as too much flux. That's like one of the #1 rules I tell people who are new to soldering. You can never have too much flux. You can always clean it off afterwards. Oops, got my depth perception all messed up again. Okay, that one acted a little weird. Again, I think it's the thermal mass of this iron. It could also be that I got a little bit of leaded solder on the tip there from my cleaner. But, okay, let me look directly at this. That'll help me. Jeez, I don't know why my hands are shaking that much. There, that's better. It's just the way I was holding the solder, I guess. Okay, let's move the whole thing up. Let me get this at the right angle. It doesn't want to cooperate. There we go. Okay, last two joints. Okay, now I'll do the same thing. First I'm going to shut this iron off. And then I'm going to give this a spray with Flux Clean. We're going to give it a scrub. Grab some paper towel again. better, although again, lots of little bits of paper towel. Of course, you can't see that with the naked eye, but up close it looks kind of gross. Let's give it another quick brush off, see if we can get rid of some of that stuff. And look at that. We've got a perfect batch of lead-free fillets and a perfect batch of leaded fillets. I find they're both just as easy to work with. They both give satisfactory results. As you can see, oh yeah, see there's that one that was acting kind of weird. I might reflow that one actually. So let me turn the iron back on. As you can see, I mean, lead-free does, you know, sometimes it acts a little funny, but that's why it's important to buy good quality stuff. And as I said, I'm not 100% sure if this solder is the exact same formulation as the, there's a brand in Japan, whose name I'm forgetting. They originated this alloy, and then they licensed it to a company called AIM, which is a well-known solder company. ChipQuick makes it, but the formulation they show on this is actually just very slightly different. The original shows 0.007 germanium and slightly less tin, if I remember correctly. Like, I remember looking at the numbers and they're almost identical, but not quite. So this might not be made under license. That might be to avoid issues with patents. I don't know. But, okay, where was that weird one? We were able to tell... Okay, yeah, it's that one right there. Yeah, see now there's no flux there. It's acting really odd. I'm gonna actually grab some solder wick. I'm gonna wick that one up and redo it. I think it was this one. I'll do the one beside it too, maybe. Come on now. Oh. There we go. Jeez. Okay, let's add a little flux. Flux for good lux. And then we'll just reflow these couple here. Gonna clean the tip off again. Actually, I'm gonna not just clean it off, I'm gonna tin it with some lead-free. If I can find the end of the roll that I just wrapped up. Oh, there it is. I'm blind. So let's just bring this in. I'm just going to tin this. Yeah, it's really blobbing up. It might be this iron. It also might be this tip. But, okay, and then we will come back up here and reflow these ones. Does that look better? Yes, those look way better. And this is also why you inspect your work. All right. So that's just a brief look at soldering with lead-free and also leaded solder, and how easy it is. And now we've got our little Pico Pimeroni Pico Plus 2 all soldered up and ready to go. Oh, we got a little chunk of something. There we go. So we've got the female pins on top and the male pins on bottom. Anyway, thanks for watching. If you have any questions, or if you want to see me doing surface mount soldering, which I'm also experienced with, let me know and I'd be more than happy to.